class. So a geometric sequence has a common ratio between terms. It's like an exponential function. So the other one had a common difference, basically a consistent rate of change. This is multiplying by a consistent ratio, just like our friend, the exponential function. So R is that common ratio. So we were finding D last time. Now we're going to find R, the common ratio. And so just like for arithmetic, for geometric, we've got the closed and the recursive that I want you to memorize the closed. That's the other formula that you need to be successful next week. And so it's very similar to what you just learned for arithmetic. A sub n equals, it's your first term. Instead of adding your common difference, you're going to multiply by your common ratio. And instead of parentheses times n minus 1, you put the n minus 1 up in the exponent because you're multiplying by r 2 times or 3 times or 4 times. So this n minus 1 is up in the exponent because it's an exponential relationship. So if we were going to jump down and do a closed formula for example 1, what is this being multiplied by each time? 4, 8, 16, 32. R is 2, right? 4 times 2 is 8, times 2 is 16, times 2 is 32. So to write out my closed formula, I'm starting at 4, and I'm multiplying by 2, n minus 1 times. So I don't multiply by 2 for the first term, right? So when I plug in 1, I just get 4 times 1, because 2 to the 0 power is 1. So see how it generates 4 as the first term. Then 4 times 2 is 8. 4 times 2 squared is 16. 4 times 2 cubed is 32. And then recursively, a sub k equals a sub k minus 1 times the common ratio. And you just have to tell the person where to start. So to get to the term you want, take the term before it and multiply by the common ratio. But recursively, you have to multiply by 2, then multiply by 2 again, then multiply by 2 again. So it doesn't generate like the 100th term for you, like the closed formula does. So the recursive formula for this one would be a sub k equals a sub k minus 1 times 2, and a sub 1 equals 4. So it's the same information, just presented in a less efficient way. So this time they want you to find the common ratio. So what is it going up by? And then find the closed formula and then use it to find a sub 6. So what am I multiplying by in example 2? Yeah. So my ratio is 3. I would recommend on a test or quiz, actually verify, okay, 12 times 3 is 36. Is 36 times 3 108? Is 108 times 3 324? Don't just assume it works, even though the first term was times 3. All right, so if I want to write the closed formula, this one would be a sub n equals 12, because that's where I'm starting. I'm multiplying by 3 to the n minus 1 power. And then I'm going to use that to plug in the number 6. So I'm doing 3 to the 5th, and then times 12. 12 times 3 to the 5th is what? Did you get 2,916? 12 times 3 to the 5th? So 2,916. All right, see if you can figure out what the ratio is in example 3. What can I multiply negative 1/3 by to get positive 1/9? What do you think? How am I going to go from a negative to a positive and then back to a negative? What would I have to multiply by? How do I go negative 1/3 to positive 1/9? What would I multiply by? Negative 1/3, right? So my starting value is negative 1/3. And guess what? My ratio is negative 1/3. So you could write it as, they kind of cancel out. It's negative 1/3 times negative 1/3 to the n minus 1. So if you want to write it as just negative 1/3 to the n minus 1, or sorry, to the n, right? Because then to the first power, you get negative 1/3. To the second power, you get positive 1/9. To the third power, you get negative 1/27. So this is, I would accept either of those formats because this is the formula. But if the ratio and the starting term are the same, you don't have to use n minus 1. You can just do n. So what is a sub 6? Let's see, it's going to be negative, positive, negative, positive. So my next one's negative, right? Is that next one 243? What's 81 times 3? Negative 1/243. And then if I multiply by 3 again, I'm going to be at a positive, right? Positive 1/729. I would leave it like that because you can see the pattern in the fraction rather than a crazy decimal. All right, I think you can do 4, 5, and 6, or try the best you can, but there's a tricky one on the back page. I can't remember which one is the tricky one. Oh, number 3. Can you look at number 3 on the back page? We don't have to finish every single one today, but I think we'll get through most of it. So this is a little bit trickier. The third term of a geometric sequence is 64. The fifth term is 1024. Find the second term. So we have the third term, and it's 64, fourth, fifth. We have the fifth term, and it's 1024. So you could do some guessing and checking, like, is it times 2 times 2, or is it times 3 times 3, times 4 times 4, right? You'd have to guess and check. If you don't want to guess and check, this is times r, and then this is times r. So if you wanted to write out a formula to solve for what r is, you'd say 64 times r squared equals 1024. You could divide by 64 on both sides and take the square root. But if you like to guess and check, you could just guess and check. So if I take 1024, divide it by 64, and take the square root, I get that r is 4. But you'd also get that by guessing and checking. So they just want you to find the second term, right? So if I have to go backwards, what would the second term be? If my common ratio is multiplying by 4, what I have to do is go back and divide by 4. So the second term would have to be 16. I think on first term, you'll have to use some critical thinking on example 4. Oh, there's one more on this page I wanted to show you. So if you take a look at number 7, depreciation, on the application problem, it says a tool and die company buys a machine for $135,000. It depreciates at a rate of 30% per year. In other words, it is only 70% of what it was worth at the beginning of the year. So they want you to find the depreciated value after 5 full years of depreciation. So I just want to point out, you want to use the 70% as your ratio because you want to know how much it's worth, not how much you have to subtract every time. So you would want to write it as A sub n, I'm starting at 135,000. My value is worth 70%. This is one case where you want to just leave it as n so that when you plug in 5, you're doing 5 complete depreciations. So you're going to plug in 5 and get the answer. But I thought you might not know what to use as your ratio for depreciation. Just like in number 8, if you have a 5% raise, what number are you going to use as your R value? That's like compound interest, right? So when you get to number 8, you're going to use 1.05 as R because it's going up by 5%. This is going down by 30%, so you're using 70.7. This one's going up by 5%, so you're using 105 or 1.05. So I think that we've had a really long class today. So let's